वेलकम माय स्टूडेंट्स, हाउ आर यू। आज भाई दूज है, सो इट्स वेल ए ग्रेट डे। टुडे we have so many fun and a lots of great delicious food. So this is basically a festive for our, because I am a Bengali. Okay, so today we introduce the second part of the interference chapter, that is fringe width of interfering fringes. What is the width of interfering fringes? Today we learn the width of interfering fringes. Previous day I told about the interference pattern and the theory of interference, that is when it causes constructive interference and when it causes destructive interference. But today we shall deal with the width of interference fringes, that is if this is central fringe or central maxima, it is surrounded by dark fringe and white fringe or bright fringe. Now, what is the width of interfering fringes? This is the width of, if here is a dark fringe, then between two dark fringe there is a bright fringe. Now, width of interfering fringe means the successive distance between two dark fringe or the successive distance between two white fringe, bright fringe. Now, how can we elaborate it? If we draw an interfering patterns, if this is intensity of central maxima, that is the maximum intensity, then the fringe will occur on these sides. Now, if this is 0, then destructive interference occurred at pi, 3 pi, 5 pi, and this is minus pi, minus 3 pi, minus 5 pi. So, the width of a bright fringe, this is the width of a bright fringe, this is the bright fringe. So, width of a bright fringe means the distance between two successive dark fringe. Here in the point of pi and 3 pi, dark fringe are formed, and in between this, if this is point 2 pi, then at the point of 2 pi we know that phi equal to 2n pi bright fringe formed and phi equal to 2n minus 1 into pi is dark fringe formed, where here n is starting from 0, here n is starting from 1. This is the difference. So, if we determine the width of the one bright fringe, then the distance between the two dark fringe we have to determine. Or if we take the width of two dark fringe, that is from this fringe to this fringe, the width of, if the width of one dark fringe, this is the width of dark fringe, then we make the distance the successive bright fringe. So, at first we draw the picture. Draw the picture of the previous day. Two slits, one is S1 and S2, are placed at a distance d from the screen. Now, the distance between the two slits is small d, and the distance between the slits and screen is capital D. Now, as P be a point where the light waves from S1 and S2 will be meet. So, the two rays, this is obviously straight line, the two rays will meet at this point, which is one is S1P and other is S2P. If this is central maxima, then or central wideband, this is central wideband CB, we can refer it CB, then the distance between central maxima and the point is taken as x or xm in some book. Now, the distance between S1 and S2 is d. So, the distance between this point, if we take it a point, then this distance is d by 2. Now, this is d. So, this distance is d by 2 and this distance is also d by 2. The whole distance is d. Now, the path difference is, as this is a rectangular, this is, if this is we know as we can get it, suppose m and n point, then S1P square is equal to S1P square equal to what we can get, this is a hypotenuse right handed triangle. So, S1P is the hypotenuse. So, S1P square is equal to S1M square plus PM square. S1M square plus PM square. I hope you will know, you have no confusion. Now, what is the value of S1M? S1M is capital D square. We write it capital D square plus. What is PM square? If this is x and this distance is d by 2, then this is x minus d by 2. So, we can get it x minus d by 2 square. Similarly, S2P square, we can get, what is S2P square? If we take this as a right angle, suppose this distance is d by 2. So, S2n square, n is the this point, S2n square plus Pn square, S2n square plus Pn square, that is d square plus, now what is this distance? This is d by 2, this is d by 2. So, the Pn square is x plus d by 2 square. This is d by 2 and the distance between O and P is x. So, ON plus OP, that is d by 2 plus x or x plus d by 2 square, x plus d by 2 square. As my board is not too large, so I have to wipe out the diagram. I hope you draw it in your own copy. Now, we can go with only with expression. So, S1P square minus S2P square, what we can get, sorry, S1P square minus S2P square is equal to, we can get d square plus x, sorry, here S2P square is larger than S1P. So, we can write S2P square minus S1P square, d plus x plus d by 2 square, this minus d square minus d square plus x minus d by 2 square. Now, if we analyze it or factorize it in a square minus b square form, then this is written as S2P plus S1P, a plus b into a minus b. If we simplify it, we get it 2x small d. Now, as the distance between the point P and the central band O is very small, this is S1, this is S2, is very small. So, S1P and S2P will be nearly equal, not equal to D, nearly equal to D, because this is enlarged picture. In practical, this will not so far. So, S1P and S2P are nearly equal to D. So, this term is nearly equal to D, S2P, then we can write as S2P equal to S1P nearly equal to D. So, S2P plus S1P means 2D. So, S2P plus S1P is equal to 2D. Therefore, S2P plus S1P equal to 2D into S2P minus S1P is equal to twice XD. Now, the path difference P equal to S2P minus S1P. If we take S2P minus S1P as the path difference, we return as P, which is path difference P is equal to, here P is not this P is the path difference, or we can write it simply path difference. Path difference is equal to twice x small d divided by twice capital D. 2 cancel out, that is x small d by capital D. This is the path difference. Remember the value x small d upon capital D. X small d by capital D. Now, for bright fringe, path difference equal to n lambda. So, we can write for bright fringe x small d by capital D is equal to n lambda. X capital D equal to n lambda. Now, for central fringe or x equal to, we can get n lambda capital D by small d. X equal to the distance between the central wideband and the point P is equal to n lambda capital D by small d, n lambda capital D by small d. Now, for nth other bright fringe, we can write it at xn. Now, if we put n equal to 0, we can get x0. What is the value of central? X n equal to 0 means 0, that is the central wideband. N equal to 1 means first bright band, x1 equal to lambda d by lambda capital D by small d. If we get n equal to 2, then we can get second bright band, that is 2 lambda capital D by small d. So, fringe width if we take it beta in some books, then it is the difference between two successive bright band, that is x2 minus x1, that is 2 lambda d by small d minus lambda d by small d. We can get x2 minus x1 or beta equal to lambda capital D by small d. So, the fringe width, that is the distance between two successive bright band, is lambda capital D by small d. This is for bright band. Now, for dark band, dark fringe, the path difference is equal to 2x small d by capital D is equal to n minus 2n minus 1 in lambda by 2, 2n minus 1 into lambda by 2. So, here we can get x is equal to 2n minus 1 lambda capital D divided by 2 small d, that is 2 to cancel out, that is 2n minus 1 capital D upon small d. Here n is not starting from for dark fringe, this is for dark fringe. Here n is not start from 0, here n is start from 1. So, if we put in this equation n equal to 1 and n equal to 2, therefore, we can get the value of x1 and x2, that is the position of first dark band and second dark band. If we put n equal to 1, what we can get? 2 minus 1, that is 1 d by small d. If we put n equal to 2, that is 2 to the 4 minus 1, 3 capital D by small d. Sorry, 2n minus 1 lambda by 2 and this is in this position 2n minus 1 lambda by 2 or dx is equal to this will be 4 and this will be 2 lambda d and 2 is remaining here, sorry, this is 3 by 2 and this is half d by 2. A 2 term will remaining in the denominator, sorry for that. So, the fringe with beta we can get x2 minus x1 equal to 3 by 2, here lambda will occur, 3 by 2 lambda capital D by small d minus half lambda capital D by small d, that is we can get lambda capital D by small d. The same result for bright fringe, here the same result for bright fringe will occur. So, we can get the fringe width between two successive or fringe width, or that is beta, that is distance between two successive bright band or two successive dark band is equal to lambda capital D by small d. From this we can find out the wavelength of the light used, that is lambda is equal to beta small d by capital D. Now, if it is immersed, now if the medium is immersed into water, a slit is immersed into water, then what we can get, beta dash, fringe with beta dash equal to lambda dash capital D by small d. Now, what is the lambda dash? Lambda dash mu equal to lambda divided by lambda dash, therefore lambda dash equal to mu by lambda by mu. So, lambda d by mu small d, that is beta by mu. So, when the slit is immersed into liquid of refractive index mu, its fringe width decreased by 1 by mu times, or simply the new fringe width will be the fringe width in air divided by refractive index of the liquid occur. So, from these questions you know the how to get the value of fringe width, that is the distance between two bright band or distance between two dark band. Next day we will go with some interesting topic about interference of light and also the theory of diffraction. Thank you.